Hi Monique and Brady, this is what you missed today. This is the second attempt at recording this. The first one I forgot to turn the microphone on. So what we're looking at today is we're looking at different shapes of curves and seeing what we get when we're looking at the first derivatives and the second derivative. So what we've got are the first derivatives, and we've got them being positive, negative, and 0. So if the first derivative is positive, we're dealing with an increasing function. If the first derivative is negative, a decreasing function. So increasing and decreasing. If the first derivative is 0, then it is stationary. We've looked at 3 stationary points: maximums, minimums, and points of inflection. We have down the side our second derivative. So if the second derivative is greater than 0, the curve is concave up. If the second derivative is less than 0, the curve is concave down. And if the first derivative is equal to 0, we're dealing with a change in concavity, a point of inflection. So putting this together, a curve which is increasing and concave up would look like that. That would be like our exponential function that we're seeing a lot of these days. A function that is concave up and decreasing, be looking like that. That looks like part of an hyperbola. And thirdly, if we have a stationary point that is concave up, we have a minimum. We're going to use that particular test later on in this lesson to show that a particular turning point is a minimum or maximum or a point of inflection. All right, if a curve is increasing and concave down, it's looking like that, and we see that with our logarithmic function. If it's decreasing and concave down, same sort of thing. And if it is concave down and stationary, we have a maximum turning point. Right, final row. An increasing curve where the second derivative is equal to 0. So we could be looking at a curve which changes concavity, say about there, from being concave down to concave up, but still is increasing. And we can have the same thing while decreasing. And that's not the only way we can do it. We can change concavity from down to up or from up to down. Either of those work. And finally, if we have a stationary point where the first derivative is 0 and the second derivative is 0, we're dealing with what's called a horizontal point of inflection, where the curve flattens out completely. Now, unfortunately, we also need to show that concavity changes on either side of these.